chapter 6, or probably the last chapter on problem example giving or problem solving, you can say, on kinematics. Okay, so now I'll move to the number 14. Here they have asked to give some example of null vectors. So what are the null vectors? Null vectors are those whose magnitude is 0 and have direction indefinite. Okay, so now if we assume the coordinate system of two dimension y and x, so any position vector from origin at any certain distance will be denoted by the position of that vector with x and y. Now this position vector must have some dimension and direction from origin towards the point itself. This is a vector, it is denoting, let's say O and a position vector. Okay, now if it is the position vector and it is a vector, now slowly if I try to reduce the length, now let's say it is move up to this also A per se, then after I will moving and slowly I am merging this A on O. So A will not be distinguished differently than O, and the coordinate of A become 0, 0. That means x is equal to 0 and y is equal to 0. So nowhere it is moving, and the origin it is 0, 0. Then the OA will become a null vector which is having dimension 0 and having some direction, but once it is merging this way on a point, there is no significant direction I can tell. So that can move, because when it is starting from O, it can move any direction in 360 degree. So once the 2 points are merging to each other, this is nothing but a single point. So the single point, if I take the direction, it could move in any direction. So this could be a null vector if I consider the origin itself, the origin of a coordinate system or a 2-dimensional or 3-dimensional, any dimension you take, the origin is a null vector. Another thing is that, let's say one is started from a point, there may be 2 or 3 races which are started through a track and moving some direction. Okay, so these are having a displacement of each of the runners, but some of the runners couldn't start and got some pen, and he has stopped from the starting point. So in this case, his displacement is 0. So the displacement 0, that means the starting point and the end point is same. So this is also an example of a null vector where there is no value of displacement. Even then, as you know, it has started some directions, and this also will move this direction only, but there is no movement of that runner. Although we can signify direction, in which direction the runs happen. So if he could move, he could move in that direction. He can move in that direction. So displacement is 0, but direction can be defined. Okay. So this is some example of the null vectors. Moving to 15. a vector of a vector of 10 root 2 units in x and y plane. So you have to find a vector of 10 root 2 units in xy plane. So if I draw xy plane is being drawn with the axis of x and y. So whatever the plane is formed by these two axes, which is a 2D plane, is the xy plane. So in this plane, any vectors which will having a dimension 10 root 2, what are the vector? So the vector which is having 10 root 2, so this basically can be denoted with this line. There could be possibilities that in the sum you will get some options, because there may be n numbers of solution. If I draw some line which is denoting a vector with the end points, here you can understand that this is x comma 0, this is 0 comma y. So any position vector from 0 to x, let's say this is I am denoting at x only, it will be having only x direction. The xi will be the vector, and this if I draw with y, so it will be yj the vector. If it is denote, so this vector can be represented as, if let's say this is resultant of this, so this can be represented as xi. So what is that? If it is position vector, this is positional vector. This could be of either any direction. I am taking it this direction. So if it's r, so r is nothing but y vector minus x vector. This also I am representing capital Y. So what is y? It is yj minus xi. So what is the result mod value of it? It will be x square plus y square, or rather I can say y square. X will be there because x is I with I na. So that means minus x whole square plus y square under root. So this will be nothing but under root of x square plus y square. Now it is given x square plus y square. The value of the vector is this square, I can say 200. So if it is 200 x square plus y square, so that may be divided into so many combinations. One could be 100 and 100, both could be 100, x could be 100, y could be 100. So in that case your vector resultant will be minus 10i, means x vector will be 10i and y vector will be 10j, and your ultimate vector will be, resultant will be 10. You need to find the vector 10 minus 10i will be minus 10i plus 10j. This could be on possibly, because 200 can be divided into so many parts. So one of such kind is this one. So in any other combination, 1 plus 199 to 2 plus 198, this could be other possibilities, but there must be some options given. So the easiest I have just shown you. So there could be any other, if it is said a open question for you, so there could be n numbers of solution. You can mention that the 200 can be broken into 1 plus 99 to up to 100 plus 100. Okay, then again you will further go, you will get the repeated one. So that could be divided into such way, and from there x could be x is equal to 1, and y could be y is equal to root over of 199. This way the different solution you will achieve, and accordingly the vector can be represented in different way. Okay. Moving to 16. If half I plus half j plus ck is a unit vector, then find c. C is a unknown here, so as it is a unit vector, if it is a unit vector, then what is the what could be the value of it? If it is a unit vector, then if it is represented as a, so I am writing it half j plus ck, and if it is a unit vector, the mod value of a has to be 1 as per the definition. So the mod value is what? Half square plus half square means x square plus y square plus z square is equal to 1. So you can remove the square root sign, so you will get 1 by 4 plus 1 by 4 plus c is equal to c square is equal to 1. So from there c square is equal to 1 minus half, that is equal to half. So c is equal to 1 by root 2. So this will be your answer. So c can take both plus and minus, that both can satisfy the equation. So both are possible. So c could be plus or minus 1 by root 2. A force F making an angle angle 60° with positive x axis has a component of 20 Newton along x axis. Write the force in vector form. Okay, so this is given that there is a force F making an angle 60°. This is F making an angle 60° with x-axis, has a component 20 Newton meter. This is a component this side, it is of 20 Newton meter along the x-axis. Write the force in vector form. So first thing you have to know what is component. So component component of a vector are the two fractions of the same vector, two fraction or two part, you can say two part of the same vector which are mutually perpendicular to each other. So it means if this has to be broken into components, so this could be broken into two such any component. Means if it is a force, it can be divided into two components whose internal angle will be 90 degrees. So it is not that it has to be divided into horizontal and vertical. It could be any angle, but ultimately the component, the fractions or the parts must have in between angle is 90 degree. And if I consider the angle which is forming with the horizontal part of it, theta, so this component will be f cos theta, which is making theta angle which is making a theta angle with the main vector, that means force. So I mean to say, so I am rubbing this part. So the math you have understood, so that I have written here. So now I have to understood the component first. Let's say this is force. Now if it has to be broken into components, there could be n numbers of possibilities or any unlimited numbers of possibilities. If it is f and if it is making angle theta with the component, so this part will be f cos theta, this will be f sin theta, but this is not the only one. Now if I assume this is another part, then this part has to be 90 degree to the other component. So this case, if it is alpha, so this will be f cos alpha and this could be f sin alpha. Okay, but your first and foremost condition has to be the component must have internal angle of 90 degree. That is the first and foremost. But after that, this is your wish at which angle and which direction you want to break into component. So these are the concept of a component that is very useful when you are balancing force diagram acting on a body. But here, if it is f, the component which is on the x direction, it is 20, and that means f cos 60, this is 20. So f cos 60 means root 3 by 2 is equal to 20. Cos 60 is equal to half, cos 60 is equal to half. So f is equal to 40. Now the question says, a force F making an angle that is the x-axis with the write the force in vector form. So that means if you have to make it into vector form, so you have to, as because this is starting from the origin, this position vector you have to identify what is the coordinate of the head point of or the terminal point of that F. So what is F? If I draw a vertical from here, so this will the component x will give, this is the component y will give. So x is already 20 is given, so once you find y, it will be easy. Now if you have found, so y is what is the that other component, that means f sin 60. So f is 40, sin 60 you know, root 3 by upon 2. is root 3 by 2, that means 20 root 3. So the coordinate of f, if it is x and y as taken, so x I have got 20 and y will be 20 root 3. So your vector will be represented f as 20 is the x coordinate, so 20I plus, as because this is also positive, 220 root 3 j. This is your representation of the vector as per the condition given. Okay, understood, I suppose. So shall I move to the next problem? That is problem number 18. A vector having a magnitude and opposite to the vector 6I minus 8j is what? A vector having magnitude 10 and opposite to the vector this. Now what is the opposite vector? This is one vector. Let's say this is denoted by this. Let's say I am assuming it is A. So A vector. Now opposite vector is the vector. Opposite vector is the vector which is magnitude wise same, but the direction is opposite, reverse. Now so the direction is opposite and magnitude also can differ, opposite vectors. So that means this is opposite vector to this. That could be possibility that this magnitude may not be same. If it is magnitude is same, then we'll call it as a specifically negative vectors. If it is not magnitude the same, then we'll call it as a opposite vector. Now see, what is the magnitude of this? If I assume this is magnitude, so this will be under root of 6 square plus minus 8 square. So what is that? It is under root of 36 plus 64. So that I am getting 10. So now the opposite vector having also magnitude 10. So this case, the opposite vector is nothing but the negative vector, because this is only opposite, but magnitude wise you can see the vectors are same. So opposite vector, if I assume is B, is nothing but B, then B is nothing but minus of A. B is nothing but minus of A. So this is, if I take minus of that, so it will convert the equation vector like this. Okay, so this will be your answer. Coming to the next, the problem number 19. P vector equal to I plus Pj minus 7k and Q vector is 5I minus 2j plus 4k, then the length of the vector length of the vector PQ P has taken first, Q is second, PQ. So the length of the PQ will be, if it is P is given, P is given a vector, Q is a vector, so we can assume these are the position vectors. P, this is position vector Q. There are two different coordinate. It is 1, 3 and -7. There has to be y, x, z, and Q is 5, -2, 4. So what is the PQ? Means from P to Q, you have to consider the direction this. So if this is R1, this is R2, this is delta R, you can take. So R1 plus delta R is R2. So what is will be the delta R then? In this case, it is R2 minus R1. See, R1 plus delta R is equal to R2. So delta R is equal to R2 minus R1. So R2 minus R1 means P. Here it is P. R2 have taken up to Q. So this will be Q minus P. So if I subtract this from this, 5 minus 1 is 4i. Then this minus this 5i, 5j, and this minus this is equal to plus 11 plus 11k. This will be the delta, that is PQ. Delta is taken as PQ because from P to Q the arrow will be this side. So the length of the vector, then the mod of PQ will be the under root of 4 square plus 5 square minus 5 square plus 11 square. So what is that? 4 plus 16, 5 5 is 25, 11 square is equal to 129, is equal to 12, 6, 162. So this will be under root of 162. That means 81 into 2, that means is equal to 99 root 2. So here the value of the length is 9 root 2. So this will be the value. Okay. Now this will be the last problem in kinematics. Then after we will finish kinematics and move on to the remaining part of the vector, and then I will follow the other motion, that is the rotational motion. Okay, so this way the classes will go. So the next problem, that is the last problem 20, angle made by unit vector I plus unit vector j with z axis, okay. So how do you do that? So that means two unit vectors of x and y taken with the z axis. That means you have to use Cartesian coordinate system. That is already understood by seeing the problem. Now if I is the unit vector towards x direction and j is the unit vector towards y direction, so angle made by I plus j. Now if I add I plus j, what would I get? If I take, this is unit vector this much, this is unit vector this much. So now if I add I plus j means this is the position vector I, this is position vector. If I add this I plus j, that means I can take, this is direction. Now what is the direction of I plus j with x axis? Now I plus j will be on the, if I get I plus j, if I adding, so the vector, anything resultant vector R, you can say, is the summation of I plus j vector, and the direction is where that this R vector will lie on the plane, that R resultant vector will lie will what I can say will yes, will lies on xy plane, x and y plane. That is confirmed. This lies on x and y plane. Now any vector which is lying on x and y plane and z is perpendicular to the plane which is anything on xy plane. Means if I consider this plane x and anything on this side, you can say minus x or minus y. If I take this axis is perpendicular, if I say this is the xy plane and this is the z axis, so any angle which will form a 90 degree to that. Okay, this plane, the x axis, this will form 90 degree. You can see this is 90 degree. So this resultant also, this resultant will make 90 degree with z axis. This will be your answer, nothing else. Understood? Just for the concept, the problem has given. Now you understand, this is a axis, y axis, z axis. This is plane where x and y is lying. This is the plane, and any vertical line on this plane, it will show the z axis. So this angle is how much? This is 90 degree. Okay, so I think it is very pretty clear. So this is the end of the journey with me for kinematics. So this kinematics can be further useful when I discuss the rotational, because some relations which will also be a part of when I discuss the rotational motion will come again. So that anyhow, that is the end of the kinematics. Now I'll move on to the remaining part of the vectors, where I've not discussed some important part, which is the vector addition by different kind of method. On that I will do some exercise also. Then after ending that chapter, I will move on to the rotational motion. Okay. So it's the end of the day today. I call it a day, and keep watching. Kindly subscribe my channel. I can see there is interest is going to see my videos, and that is giving me a confidence to come with more kind of different problems and the theories that will be useful for you in your academic. Thank you for watching.